Today I'm going to present about automated fact-checking of climate change with a small subtitle of from small language model to large language model, from fine-tuning to RAG. This is one of my research interests. I'm currently studying at Chinese University of Hong Kong, year 3 student. I'm doing an exchange at TOM, so I'm very happy to present to you guys. So about background and motivation. So this is one of the things that sparked my interest is that I remember Donald Trump said, it's freezing in New York. Where the hell is global warming? So from here, we can tell that actually a lot of climate change misinformation is happening online on the internet. And such misinformation can manipulate and manipulate the understanding of climate change and polarizing the climate change debate. So currently the algorithmic fact checkers are not fully automatic, but they are rather as a tool to assist human fact checker. But with the rapid development of transformer models, so we have the opportunity to explore more of the potential of fully automated fact checking. So previous work are majorly on small language model like BERT, RoBERT, and we try to fine tune it to make it as a fact checker. So here is a common 3-step pipeline model. So you have 3 models here. The first model is doing the document retrieval. In this case, it doesn't have to be Wikipedia, could be the whole web. And after you get the relevant document, you get another model to do the sentence retrieval. And with the sentence retrieval, it acted as evidence for the claim. So you pair the claim and the evidence, and it will produce a final verdict whether the claim is supported, refuted, or not enough information to fact check. So here is a claim verification kind of the infrastructure. You have sentence 1 as a claim, sentence 2 as the evidence. You get a separation token in the middle and produce the final class at the end. So the final class could be, in this case, support, refute, and not enough information, right? So in climate fact-checking domain, there is one particular data set called climate fever. It's actually built on fever data set, which is very famous for common fact-checking tasks. So here we can see we have a claim here. Global warming is driving polar bear towards extinction. So you have evidence one giving the evidence sentence which support the claim. Evidence 2 give and not enough information evidence to is not able to show that this evidence is supporting or refuting, so it gives not enough information. But one thing I want to address here is that this data set have a huge flaws, which is they don't have enough refute labels, which is very interesting because in fact-checking domain, we want to find out more misinformation, right? We want to try to refute more claims that are not true. But in this data set, it's actually find that it's only have 800 claim evidence pair that show refute. So last year, I was working on a paper called Fine-Tuning Pre-trained Transformer for Climate Claim Verification. So basically, what I contribute on this data set is that I want to expand it with more refuted claims, right? So I found an very interesting website organization which do climate claim fact checking called the Climate Feedback. So scholars on this website will regularly to fact check claims, provided evidence, so to try to tackle with misinformation. And I find it interesting because it actually kind of can integrate into the data set in the fact that in the website, they have 12 classes. And for integrating to the climate fever data set, we can simplify those verdict into 2 classes, incorrect or correct. So with this idea, here is a more clear demonstration that with a claim, there's a verdict, there's also evidence. We can extract this by web scraping, and then, interestingly, the new data set that I created is actually have 50% more refutes, which is a huge improvement. And I also fine-tune it on different models, which in this case, Bull-Butter works the best with 73% of accuracy, which is actually similar to previous state-of-the-art model or even better. So here, another thing I want to point out is that actually GPT-2 decoder-only model and T5 encoder-decoder-based model is actually work worse than encoder-only model. But maybe have to be like further investigation. So not too much academic paper is working on the difference between them, but in here, I think is a very interesting comparison. So we can play with it a bit actually, because I put it on Hugging Face. So here with the claim that the Great Barrier Reef is experiencing the most widespread bleaching ever recorded. The evidence is that in a report in March 2016, report stated that coral bleaching is more widespread. So basically, from what we can tell is supporting, right? So let's compute it. Yeah. So it is supporting. What if I change the claim? Let's say it was not more widespread. So it should be refilled, right? So it also showing refilled. Let's say I'm typing something unrelated. Oh, not enough information. So this model work very well, but here is a problem. I'm only doing one of the model here, which is the claim verification, but without document retrieval and sentence retrieval, my models can't support or do anything in reality, right? But this pipeline also have one crucial problem, is that whichever one is wrong, the rest is wrong. So let's say the document retrieval, they get the wrong document, the whole fact-checking process is wrong. So after I do this interesting research for myself last year, some interesting work actually happened this year in January. So this is the latest work on large language model with RAG. So when we work with large language model, we always have to think about, should we reduce hallucination by fine-tuning or RAG? In the case of minimizing hallucination, actually RAG works better because you have a database that is constantly updated and works better in large language model. You use less cost, less computational power to do it. So here is a paper which work on RAG and large language model. They call it the Claiminator. So this paper is on automatic fact-checking of climate change claims with large language model. They present a Claiminator. So the RAG is based on IPCC reports and some other peer-reviewed scientific literature as the database. So one interesting thing here is that they employs a mediator advocate framework, which I will talk about later. So it has a claim also with climate feedback, which I introduced previously. And they even put in an advocate with climate science denier perspective, which I will talk about later. So what's the mediator advocate framework? So interesting thing is that whenever we fit a climate change claim, we want to fact check it, we give to advocate A, advocate B. There can be hundreds of thousands of advocates, but the idea is that with advocate A, let's say it's IPCC. So it will retrieve documents from IPCC, put in chunks, information retrieval. You get the most relevant information related to the climate change claim on the IPCC report. You prompt it into to make it be able to give the verdict and reasoning. And then with advocate A, advocate B, let's say advocate B is other scientific report, advocacy is other information, other reports. So here the mediator, what the mediator do is to summarize those ideas. Let's say if they think they have different opinions, let's do another round. So here is a follow-up question. Let's do another round. So it is an iterative debating process, which is very interesting. I've never heard of it before, but maybe it's a quite of big, like a progress in fact checking. So yeah, that's it. So here in the debating process, let's imagine it as there are 6 people. We have IPCC, we have WMO there, or international government organization. ABSCC is and S1000 is some kind of scientific literature abstract. They didn't get the exact paper because I believe it will be very computational intensive. We have also GPT-4, which doesn't have a RAG system to support it, but basically the plain GPT model. And also we have the mediator. So they are kind of debating whether this claim is proved to be right, proved to be wrong, or we actually don't have enough information. So we give a final verdict of not enough information. So they also test it on climate feedback, but instead of 2 classes, they actually test it with 7 classes, 5 classes, and 2 classes. So here you can see it's more labels and more precise verdict for reasoning here. So actually they done a quite great job. The Cleminator model does a quite great job. As we can see here, let's say the 2 class without not enough information, it get an accuracy of 97%. And even 5 class maybe worse, but 64%, and 7 class 62%. So the result is actually not that bad, and it's a big progress compared to previous work with small language model, because with small language model, most of the researchers work on that area. The models reach as high accuracy as 70-something% with 3 class classification, but here we guess something like 90 to 97%. So pretty impressive. So an interesting things they also experimented with is that they add a denier perspective into the table. So NIPCC is actually, you can think of it as the opposite of IPCC. So they are climate change denier. So they also put them into the Cleminator model. So we have Cleminator A, which have all the model I mentioned with this NIPCC model. So also for Cleminator B is actually IPCC versus NIPCC. So interesting thing is that the models ask more follow-up question compared to the plain Cleminator language model, which means that the debate is getting more fierce, right? It's getting more fierce debate here. And let me show you the result. Even after adding the denier perspective, you actually get an accuracy somewhere around 90%. So even with denier perspective, you can get a good result. So meaning proving that they have a robust performance. So let's talk about limitation. So the limitation of Cleminator, although it works well, is that we need a recency of information. So in climate change science or other science domain, we actually have evolving evidence or data, right? But with the Cleminator infrastructure, we have a static database. So it won't constantly update it, and that's very needed. And also source quality and comprehensiveness. Actually, they are using a narrow range of sources. We only have 5 advocates in previous mentioned slide, but maybe we actually need to adopt a broader base of sources from other academic journal, news report, others, so on. And also the technical infrastructure of this paper is completely built on GPT-4. So an open source model may be needed for climate science because we need to add transparency and control. Lately, we know the new model, Tianwen, is actually performing better than Llama 3. So it is possibly a good model to try on. So to resolve this limitation, actually, lately I've been working with how to improve the RAG system. And I came to the idea that we may be able to use knowledge graph. So this is a knowledge graph, open source knowledge graph by Allen AI. So they have application called the Semantic Scholar. Basically, it's like Google Scholar but open source. So basically, you can ask anything there, and then it will provide you to the most related scientific literature. So I believe it will be a add-on to the Claminator models. So I actually tested it with the claim that Amazon near tipping point of switching from rainforest to savanna. So when we put the claim into the Semantic Scholar API, it actually retrieves some very related information. Here we can see the first paper it retrieved is actually Amazon rainforest near tipping point to savanna. So it's basically referring to my claim. So it actually retrieving something that is very, very relevant. So I propose a framework that, let's say, whenever we have a claim, we can feed it to the knowledge graph, retrieve the top papers, and then we get the papers, we put in a vector database, and then we also can query to Llama. We based on this evidence, we create reasoning and verdict. So I actually experimented with it. For the prompting, I adopted for the Llama 3 model prompting, I adopted the IPCC guidance on uncertainty. So basically, it's a guidance for you to respond to something that's uncertain, which is also adopted in the Claminator prompts. So the prompts actually emphasize on two key ideas. So it is also in the guidance notes, which is evidence and agreement. So what do you mean by evidence? Evidence means that the conclusion is supported by numerous high quality studies. And the agreement is the level of consensus among expert and scientific study on a particular issue. So with the large language model will evaluate these two key perspectives to try to give the verdict at the end. So we can test it out. Actually here, maybe it's blocking. No? So here, let's query the claim Amazon near tipping point of switching from rainforest to savanna. So here it will retrieve the most, I only choose 3 papers. So here it will retrieve 10 chunks, and based on these contents, it will generate a response. So let's wait. So it's pretty impressive that I can run a language model on my MacBook. I'm using MacBook Air, but I can run big models like Llama 3 on this desktop. Yeah, so here you can see the models showing that is giving a verdict that is correct. It is saying the claim is correct. Let's see the reasoning here. Based on okay, you mentioned about carbon sink, become carbon emitter. Yes, it's showing that from the context, it actually have a growing body of evidence that's approaching a tipping point. So based on this evidence, the model given a verdict that is correct. So it's very interesting. So for future research, I'm thinking we can definitely test it with bigger model. Currently, we are using Llama 3 8 billion. It's really small models with small context window, and we can try bigger model like GPT-4 or Llama 3. And actually, what I believe is that knowledge graph is not enough. We still need IPCC, WMO sources. So we have to integrate them, and also we have to prioritize reports like IPCC, which is most important climate science material in this domain. So we should prioritize it in the information retrieval process. And actually, I think this idea is quite interesting in the fact that it can do more than climate fact checking because it's running on a scientific in a academic scientific literature knowledge graph. So it is possible that it can fact check across other scientific domain. So this is the end of my presentation. Thank you.